Good morning to all. Let us solve a problem on impulse turbine. Okay. So the problem is given as in D-level turbine, the steam issues from the nozzle with velocity of 1200 meter per second and nozzle angle is 20 degrees. The mean blade velocity is 400 meter per second and inlet and outlet angles of blades are equal. The mass of steam flowing through the turbine per hour is 1000 kgs. Okay. So what we have to calculate? We have to calculate the blade angle, tangential force on blade, power developed, blade efficiency, relative velocities of steam entering the blade. So these are the values what you have to determine. So the D-level turbine is known as simple impulse turbine. D-level turbine is nothing but simple impulse turbine. Okay. So here the blade velocity coefficient is taken as 0.8. Okay. Now let us study the data given. So here the absolute velocity of the steam entering the nozzle is nothing but C1. C1 is equal to 1200 meter per second. Nozzle angle alpha is equal to 20 degrees and the mean blade velocity, that is the linear distance traveled, mean linear distance, CBL is equal to 400 meter per second. The inlet angle is equal to outlet angle, that is theta is equal to 5. And blade velocity coefficient CK is equal to 0.8. So K is nothing but, blade velocity coefficient is nothing but ratio of inlet velocity relative angle to the outlet relative angle to the inlet relative velocities. Okay. So mass of steam is given as 10,000 kg per hour. Okay. Now we are going to construct the combined velocity diagram of impulse turbine. So we used to solve the problems on impulse turbine or reaction turbines by drawing the combined velocity diagram. So this is the combined velocity diagram of D-level impulse turbine as per data given in the problem. Okay. So let us learn how to construct the combined velocity. So before going to draw the combined velocity triangle, first of all, we have to remember the terminologies which are placed at particular place. So like that alpha, beta, theta, phi, C1, CR1, so C0, like that we have to remember the terms which are placed at that particular position. Okay. So now, first we have to construct the combined velocity triangle. First we have to assume a suitable scale. Okay. So suitable scale means as per space availability in our sheet or in our exam paper, we have to select the suitable scale and as per given data. So let us assume here the velocity is given as 1200 meter per second. So if velocity is 1200 meter per second, let us consider the 100 meter per second is equal to 1 centimeter. 100 meter per second is equal to 1 centimeter. Otherwise 200 meter per second is equal to 1 centimeter. That is the scale we are assuming. Okay. So now like that we can assume the scale as our requirement, as per requirement and as per the availability of space to draw. Okay. Now selecting a suitable scale, first we have to draw the linear velocity CBL is equal to 400 meter per second. That is represented with the symbols LM. By means of representing the symbol LM, we used to draw the CBL value. Okay. So now from point L with nozzle angle alpha is equal to 20 degrees, let us construct a line. With angle of 20 degrees. Okay. So by means of using protractor at the point of L with an angle of 20 degrees in negative direction. So let us draw the construction line. Okay. Now from point L, cut with the length of C1 is equal to 1200 meter per second and make it as point S. Okay. Now from point S, now join S and M. Join S and M. Okay. And after that, extend the line LM to the left end, until to the left end, and construct the line of MP. Construct a line, we extend the line and draw the perpendicular to the particular point of S. Perpendicular to the point of S, and wherever the extended line of LM and the perpendicular line from the S meet together, represent P. Represent that point as P. Okay. Now we can measure the value of CR1 and value of CW1 and value of CF1 and value of theta by means of scale measurements and angle measuring instruments. By means of scale measurements and angle measuring instruments. Suppose the CF1 length is 10 centimeters and we are assuming the scale 1 centimeter is equal to 100 meter per second. Then CF1 will become 1000 meter per second. Like that, we have to, by multiplying with the scale, we can determine the value of CF1, CW1, CR1 and CR1, and angle theta also we can measure. Okay. Now see from the obtained diagram, the theta is theta is obtained as 30 degrees. Since the problem it has given that inlet angle is equal to outlet angle, then theta is equal to phi, that equal to 30 degrees. 30 degrees. So from the measurement with the suitable scale, the CR1 value is obtained as 830 meter per second, and we know that the velocity coefficient K is equal to CR0 by CR1 equal to 0.8. From this, we can determine the CR0, that is the exit relative velocity. So, relative velocity, that is CR0 is equal to 664 meter per second. Okay. Now we know at point M, make an angle of 30 degrees. Since theta is equal to phi, with an angle of 30 degrees, construct a line, okay, and cut on the line, with the length of 664 meter per second, and represent it as point N. Now join the line LN, join L and N. Produce the line meeting the perpendicular line drawn from the N to Q. As the procedure done in left direction, the same procedure has to be done in the right side direction. So by constructing this, the final velocity diagram, combined velocity triangle is done. Okay. Now the problem, what he has to determine? He has to ask you to determine the blade angles. So what are blade angles? The inlet blade angle is theta and outlet blade angle is phi. So now the theta and phi are 30 degrees. And what is the relative velocity of the steam entering the blade? So the blade velocity, relative velocity of the steam entering the blade, that is CR1. So CR1 is 830 meter per second that we have determined. And next he has asked for tangential force on the blade. So for tangential force means MS into CW1 plus CW2, because the vril velocities are tangential components, or velocities are tangential components of blade. So hence you can take it as MS into CW1 plus CW2. So now MS is given as mass of steam is given as 1000 kg per hour, and CW is obtained as 1310 divided by, if you convert into the seconds, then I used to get it as 1000 by 3600, that is 363.8 newtons. That is the tangential force on the blade. Okay. Next, power developed. Okay. So the power developed is nothing but the ratio of work done divided by 1000. So work done is MS into CBL into CW divided by 1000. Okay. So mass of steam is 1000 and linear velocity is given as 400 meters per second, and CW is obtained as 1300. Okay. Divided by 1000 into 60 into 60. So 1000 is for conversion into kilowatts, and 60 into 60, that means conversion of kg per hour into kg per second. So finally the power developed is obtained as 145.5 kilowatts. Okay. Next, blade efficiency. Okay. The blade efficiency is 72.8%. Okay, so what is blade efficiency? The blade efficiency is nothing but the ratio of work done by change in the enthalpy, that is cutting back blade efficiency, that we used to obtain it as 72.8%. Thank you.